Welcome back, folks. We're still looking at our first DC analysis of a BJT circuit. And right now, we want to check our assumption. Our assumption was that the circuit was in the active region, and we want to check that assumption to make sure it's true. There's two ways to do it, so I'm going to cover the first one here. And then in the next video, I'll cover the second one. Okay, so same circuit. I even cut and pasted off the old image because we already found the node voltages. And that's a good first start. Once we have those node voltages, we can go find anything we want. Okay, except the stylus for my pad. There we go. Got it. Okay, so when we want to check our assumption, one way we can do it relies on kind of the underlying physics of the BJT. And we can do that by checking the individual biases of the two PN junctions. Okay, so we had our NPN. I'll draw it vertically this time. It's essentially the same, right? We had an N, a P, and an N, and here's our collector, our base, and our emitter. Okay, and we essentially have two PN junctions, and we can figure out the region of operation. Okay, it's either cutoff, active, or saturation. Those are the three that we're most interested in. Okay, we can figure out what region we're in based off of the bias of the base emitter junction and the base collector junction. Okay, so I'm saying from this P to this N, what's the voltage? And from this P to this N, what's the voltage? Okay, for active, we want to see that the base emitter junction is forward biased, and we want to see that the base collector junction is reversed biased. Okay, we can go check that right now, but let me fill in this table because I think it's a good thing to have all in one place. When we're in the cutoff region, both junctions are going to be reverse biased. Okay, reversed and reversed. And then for saturation, both are going to be forward biased. Okay, so all that's left to do is to say, okay, let's look at these voltages. We can find these voltages based on the node voltages. Okay, so from base to emitter, what's the voltage? And we can say, well, from base to emitter, what's the voltage? And if we're finding the voltage at the base with respect to the emitter, we can break that out and say it's the voltage at the base with respect to ground minus the voltage at the emitter with respect to ground. Okay, the emitter, if you recall from this circuit, was grounded. So this is simply 0.7 volts minus 0, which is 0.7 volts. And we can say that that is forward biased. Okay, simple enough. Okay, here's the base collector junction, and I write those in that order very particularly because if this is positive with respect to this, then we know it's forward. Or if it's above 0.7, if it's in that neighborhood or above, then we're in good shape. Okay, so this is going to be the voltage at the base minus the voltage at the collector. Okay, so let's see, we had 0.7 was our voltage at the base, and 3.5 is the voltage at the collector. So when we do that, we find that it's negative 2.8 volts. Okay, and since that's negative, we can say that one is reversed biased. Okay, so these two here match what we would expect for the two PN junctions in the active region. Okay, so we're checking against that table. All right, so this feels good, right? Like we're like, oh, I just got to find the node voltages. I find these other little voltages, and I'm good to go. But there's, of course, a problem with it. The 0.7 was based on our assumptions, so we don't always, this is always going to look like it's forward biased because, well, that was part of the assumption we made to find the node voltages. Okay, so there will be cases, and I will demonstrate them, but there will be cases where it's a little ambiguous. So we're like, I think it's active. It could be cut off. We don't know. So that leads to maybe needing another way to validate this assumption. And that's what I want to look at in the next video. And I like that way for a few reasons as well. Okay, so this feels like it's succinct and clear, but it will lead to some ambiguity. Stay tuned if you want to learn the next way to do this. All right, stay tuned and good luck, folks.